Hey folks, welcome back to our course in trigonometry. I wanted to do one more video about some applications. Now this one's a little bit different. This is applications of finding distances using compass bearings. Okay, so we're going to imagine that we're kind of looking at a map here. So that direction is north, this direction is east, and of course we've got west and south. Okay, now the way these bearings are given to us is they tell us the angle from the north-south line. Okay, so let me give you an example or two here of just some compass directions. Okay, so if we were talking about north, 55 degrees east. Okay, the first direction is where you're going to be starting. Okay, you start there, along that line. This is the angle of rotation, and this is the direction of the rotation. Okay, so north, 55 degrees east would mean you're heading in that direction, where this angle is 55 degrees. Okay, so your first direction is always going to be either north or south. If they tell you north, then you're starting from here, and then they'll give you the angle that you rotate through and the direction. So 55 degrees east, you rotate this way. If it was 55 degrees west, we would go the other way. Okay, so starting direction, angle, and then the direction of rotation. Let's do an example where we have south. So let's do, I'll just pull another one right here out of our textbook, and we'll do south 35 degrees west. So that's our north direction, this is our east direction, of course south down here, west over here. Starting here, rotating toward the west, 35 degrees. Okay, so that's your bearing if you're doing south 35 degrees west. So the reference is always to that north-south line, because if you have an actual compass, then your compass points north, so you'll have the north-south line for you, and your compass usually has angles printed around the perimeter, around the circumference of the compass, and you can find your bearing by looking at that. Okay, so that's how to read bearings. So let's do a little application where we find some distances if we know the bearings. Okay, so where's that boat problem? There's a problem I wanted to show you here. Okay. So a boat travels on a course north. A boat travels on a course bearing north, and then 37 degrees 10 minutes west, for 79.5 miles. And the question we're asking is, how many miles north has the boat traveled? Okay, so our boat is going on this course, north, 37 degrees, 10 minutes west, 79.5 miles. We're asking how many miles north our boat has traveled. Okay, so let's start with a picture. North, east over there. Now that's our starting point, so we're starting there. We're rotating through this angle towards the west. Okay, so we're over here like this, where that angle is 37 degrees, 10 minutes. Now, we should get our calculator there and convert that to decimal degrees, right? 37 plus 10 over 60, 37 point, oh gosh, I think it's like 167. Let me check with my calculator really quick. I'll probably need it for the computations anyway, so it's good I have it out. Okay, 10 divided by 60. Yeah, so 0.167 degrees. So 37.167. Okay, now we know that this distance is 79.5 miles. Now, that's not quite what the question is asking, though, because this is not straight north. So we're going to imagine projecting onto the north axis like this. Okay, so the question we're trying to answer is, what is that distance? Okay, what's the displacement straight north if we go along this course? So we're thinking about the trigonometry that we know. Okay, we've got a little right triangle here, and notice this is a very unusual case going to the y-axis. You have to do this with bearings because our angles are always given from the north or south, north-south line. So let's look at what we know. We know the angle, we know the hypotenuse, we want this side, which is adjacent to the angle that we know. So we got adjacent and hypotenuse involved in the mix, so we should use cosine. So cosine 37.167 degrees is equal to adjacent over hypotenuse. So let's call it distance d. Let's get an actual variable name here. So that's my distance d over 79.5. So if this equation is true, then we can solve it for d. We can multiply both sides by 79.5, and then we'll have d by itself. You have d equals 79.5 times cosine 37.167 degrees. All right, so I'll do the computation here, 37.167. I'll take the cosine of that on my calculator, multiply that by 79.5. Okay, my calculator is giving me 63.35, blah, blah, blah. I'm guessing I should probably go to 3 significant figures there, so we'll call it 63.4 miles north. Okay, so how far north has the boat gone? Well, 64.4 miles north. It's gone some distance that way too. It's gone some distance west because it's got a northwest bearing. But the components here are, that's the amount north you'd have to go, that's the amount west you'd have to go. So getting to this position involves traveling 64.4 miles straight north. And notice what we used. Well, we used our angle. We fit in a right triangle. We got the hypotenuse. We want the adjacent. So we're bringing in cosine because that's hypotenuse over adjacent. Or sorry, adjacent over hypotenuse. And then we work out what we need to work out. Okay, so another neat little application of these this right triangle trigonometry.